audience, my lovely audience. Is that everybody? Yeah, okay. Sweet. Most of you have probably heard about Einstein's theory of relativity. Maybe you heard about it in the news last week, or maybe you've seen the movie Interstellar, which is the concept of relativity when the astronauts age slower than the people on Earth. Einstein's theory of relativity is a crucial and fundamental part of physics and understanding space-time. I've come to this conclusion after much research on the topic from a variety of sources, including Einstein's actual paper on relativity published in 1935. Today, I'll share with you Einstein's theory of relativity in simple terms so that you can better understand how it affects your everyday life, or how it could, if you lived in the future, I guess. There are two postulates that lead to Einstein's final conclusion. First, he has a postulate about classical relativity. Okay, so the first postulate, imagine that there are two children on a flatbed truck traveling 60 miles per hour. I'll show you guys a diagram. And throwing a ball back and forth at 20 miles an hour. To the kids in the truck, it looks like the ball is moving at 20 miles an hour, but to someone outside the truck, it looks like the ball is moving at 50 miles an hour. More so, someone watching from space would see the ball's movement on the truck plus the movement of the rotation from the Earth, and you would keep going and say that someone watching from our galaxy would see the rotation of our galaxy plus everything else mentioned. But basically, what I'm saying is everything is always moving, and so movement speed is only measured relative to something else. So see this, the truck is moving forward at 60, but the ball is moving at 20, and so someone on the truck would see the ball moving at 20, but the person off the truck would see the ball moving at 40 because of the truck's movement as well. It's kind of confusing, but this is Einstein's first postulate of Einstein's first theory of relativity. The first postulate of Einstein's theory of relativity. As your reference frame is moving at a constant rate, like a car, the Earth, or our galaxy, the physics are the same regardless of velocity. I'm not just making this up. All this information is described by Adam Becker in his video on relativity with the BBC. That's the first part of Einstein's theory of relativity. Pretty simple, right? Yeah. The second part of his theory deals with how light travels. At first, people hypothesized that light needs a medium to travel through, kind of like how sound travels through air. But an experiment by Michelson and Morley proved that there is no such thing. This experiment is described on Wolfram Research's website, but I'll spare you the details. The important part is what the results of the experiment were. So basically the experiment, to put it shortly, they reflected some light off different directions, and they saw that regardless of which direction you reflected the light, it always made the ssame pattern, which meant that light didn't travel through something that was called an ether at the time, but they realized it doesn't exist. Why was this important? After this was discovered, Einstein realized that the movement of light travels the same regardless of the reference frame. Still pretty simple, right? So far we've learned that all movement is relative and that light doesn't require a medium to travel through. What makes this theory so revolutionary, you ask? Well, time dilation. The reason for Einstein's theory of relativity is so famous is because of a concept called time dilation. Time dilation is the idea that as you age slower, if traveling at a very fast speed relative to someone aging on Earth. This is explained by Max Planck Institute for Gravitational Physics. This is because when you're moving at such a tremendous speed, everything takes longer to happen. From a bodily level all the way to an atomic level, everything will have to travel slightly farther to do what you need to do. This is what slows your aging. I know this idea is a little far out. It's a little far out that Einstein reached its conclusion. Actually, before I talk about that, I'll show you guys my final piece of visual aid. And so you see time dilation, right? So this person on Earth, his little atoms in his body, those like quantums and all those weird things, don't move very far, right? But the person traveling super fast, like across the page, all his stuff has to move really far. See, this is the person that's not moving fast. This is the person that's moving fast. And then so at the end, you can't really tell on the camera, but this guy's old and this guy's young because one is moving fast and one is moving slow. And when I say fast, I mean like at almost the speed of light. So not 60 miles an hour, 100 miles an hour, but like thousands of miles per hour, billions of, I don't know how fast the speed of light is. Okay, so anyway, this idea is a little far out that Einstein reached this conclusion just from his previous two postulates almost a century ago, but he definitely did. In his journal entry in the 1935 Physical Review, he concludes that while we have thus shown that the wave function does not provide a complete description of physical reality, and so the wave function was the old way of describing things without time dilation and things like that, we are left open to the question of whether or not such a description exists. We believe, however, that such a theory is possible, and so the theory that he was talking about that could be possible is this, and we now know that it is possible. And that's what's so revolutionary about his theory. It explains an entirely new realm of the physical reality that's previously unexplored. So, today we've gone through one of the most amazing scientific discoveries in the history of mankind. We've learned about Einstein's postulates of classical relativity and light, and found out how they combine to make time dilation. This discovery is a crucial part of how mankind understands everything in the universe. And maybe when humankind is able to travel at close to the speed of light, we can experience Einstein's theory of relativity firsthand. Thank you. One more look at my wonderful audience, because they didn't go anywhere. Okay, go Bears.